Hello everyone, we are going to study tissue processing. So the aim of tissue processing is to embed the tissue in a solid medium that is firm enough to support the tissue and give it sufficient rigidity to enable thin sections to be cut, and yet soft enough to enable the knife to cut the sections with little damage to the knife or the tissue. So to embed the tissue in a solid medium so that we can cut thin section, that too will not harm the sections or the knife. Steps of tissue processing. First is fixation in 10% formalin. After fixation, dehydration, then clearing. After that, impregnation, then embedding. After embedding, tissue cutting, then staining, then mounting. These are the steps of tissue processing and the duration required. So first is fixation in 10% neutral buffered formalin, overnight fixation. Then dehydration by alcohol, the graded alcohols, 50% alcohol, then 70%, 90% and 100% alcohol. Tissues, they are placed in alcohol dehydrating agent for 1 hour each. Then in xylene, 70% xylene and 100% xylene for 1 hour duration. Then for impregnation, the tissue is placed in the molten wax, that is paraffin wax, and it is overnight duration. So total time it will take is 2 to 3 working days. This is the manual method. Now this is the automatic tissue processor. In this tissue processor, 12 stations or 12 jars are there. 1 jar for formalin, then 6 jars for alcohol, 3 jars of xylene and 2 jars of molten paraffin wax. So we can fix the tissue, process the tissue after fixation by manual method or by automatic tissue processor or histokynate. So dehydration. This is the first step in processing of fixed tissues. That is, after fixation, dehydration is the first step, which involves the removal of aqueous and some lipid tissue fluids by variety of compounds. So common dehydrating fluids are ethanol. Ethanol is most commonly used dehydrating agent or dehydrating solution. It is clear, colorless, inflammable liquid with pleasant odor. It is hydrophilic and miscible in organic solvents, but it is very expensive. Another dehydrating fluid is acetone, used widely in manual techniques. It is also clear, colorless, inflammable liquid, but with pungent odor. It is miscible with water, with ethanol, and most organic solvents. Acetone is more volatile and more rapid in action than ethanol and methanol. It causes brittleness of the tissue if treatment is prolonged. Third dehydrating agent is methylated spirit, that is combination of methanol and ethanol. Fourth is methanol, then propanol or isopropyl alcohol. Solid dehydrant is anhydrous copper sulfate is placed in higher grades of dehydrating alcohols. So copper sulfate is placed in last jar, higher grade. So last jar of dehydrating alcohol, forming a thin layer at the bottom. So anhydrous copper sulfate, which is white in color, that will turn blue on exposure to water. So blue colored copper sulfate indicates that alcohol are contaminated with water and it should be replaced with fresh dehydrating alcohol. Then chemical dehydration, it can be adopted for rapid processing. Fluid used are 2,2-dimethoxypropane 100 cc and concentrated HCl 0.05 cc. After dehydration, clearing. Next step is clearing. Clearing relates to the appearance of tissues after they have been treated by fluid chosen to remove the dehydrating agent. So these fluids have a refractive index similar to proteins, hence render the tissue translucent. A clearing agent should be miscible with both dehydrating agent as well as the embedding agent. Selection of clearing agent must be based on speed of removal of dehydrating alcohol, ease of its removal by molten impregnating material, gentleness towards the tissue, flammability, it should be less toxic, less flammable, and should be cost effective. Clearing agents, first is xylene. Xylene is most widely used clearing agent and is an excellent and true clearing agent. It is satisfactory for tissue blocks that are 3 to 4 mm thick. But it has few disadvantages. Make tissue excessively hard and brittle. So tissue should never be left in it for more than 3 hours. It is highly inflammable and it causes excessive shrinkage of the tissue. And it is not suitable for brain and lymph node tissue. Other than xylene, toluene can be used as clearing agent. It do not harden the tissue, but its action is slower than xylene and benzene. Chloroform can be used. It is best for larger blocks and for nervous tissue, lymph node, granulation tissues. That is delicate tissues and higher cellular specimens. Specimen with higher cellularity like lymph nodes and delicate tissues like nervous tissue and granulation tissue. Then benzene, it is toxic. Carbon tetrachloride could be used, paraffin, petrol, carbon disulfide, amyl acetate, methyl salicylate, cedarwood oil, clove oil, inhibisol, they all can be used as clearing agent. Now after clearing, impregnation. Once the tissues are cleared in xylene, they are impregnated with paraffin wax. So what is impregnation? Impregnation means intracellular and extracellular deposition of wax in tissues. So deposition of wax intracellularly and extracellularly so that tissue acquires a firm consistency that enables an easy cutting later on by microtome knife. The volume of impregnating medium should be at least 25 times the volume of the tissue. Paraffin wax has been found to be the most satisfactory embedding material till date. The embedding medium should thoroughly penetrate the tissue in fluid form and solidify with little damage to the tissue. So factors influencing the rate of impregnation. First is agitation. Agitation enhances the interchange of fluids between the tissue and its surrounding medium. Heat increases the rate of penetration. Viscosity. Larger the molecule, higher is the viscosity and slower the rate of penetration. Vacuum removes air bubbles from the trapped tissue, bringing the processing fluids into more intimate contact with parts of the tissue. So vacuum is important. It removes the air bubbles from the trapped tissue, bringing the fluid into direct contact with the part of the tissue. Treatment of hard tissues, Lendrum's method. The tissues, example tendons, nails, dense fibrous tissue, masses of keratin, etc., they should be softened by Lendrum's method. In this, wash tissue in running tap water overnight to remove the fixatives. So, overnight washing, then place in 4% phenol in 70% alcohol for 1 to 3 days. Now, after impregnation, embedding tissues in paraffin wax. Paraffin wax is highly popular embedding medium. Melting point of paraffin wax is 56 degrees Celsius. The paraffin wax should be heated 2 to 3 degrees Celsius above the melting point of wax for embedding, for manual processing. Paraffin wax additive. What are paraffin wax additives? The additives that added to the paraffin wax to increase hardness in order to cut thinner sections. It increases hardness in order to give necessary support in sectioning harder tissues. It increases the stickiness of medium to aid the production of serial sections of ribbons, and it alters the crystalline structure of wax, that it decreases the crystal size. So, additives are beeswax, resin, rubber, bayberry wax, stearic acid, microcrystalline wax, etc. Precautions taken while embedding or before embedding. The wax used must contain no traces of clearing agent. No dust particles be present. Immediately after tissue embedding, the wax must be rapidly cooled to reduce the wax crystal size. So, wax crystal size are reduced by rapid cooling immediately after embedding. So, molds, they are used for embedding, in which the molten paraffin wax is put. L molds or Leucard's mold, trays or cups made of tin or stout paper, tissue tech system, and disposable thin plastic embedding molds. So instead of paraffin wax, we can also use paraplast, ambidol, or carbowax. These are the substitute of paraffin wax. Paraplast is mixture of paraffin and synthetic plastic polymers. Now, orientation of tissues while embedding. For most tissue block sections, they are cut from larger area of the tissue, but there are many important exceptions. The tubular sections, they are cut transversely. Skin cut at right angles to the plane of surface, as also the tissue from GIT and any other epithelial surface, so that we get all the layers. Muscle biopsies, they are sections in both transverse and longitudinal planes. If particular tissue feature is present only on one surface, sections may be taken from that surface. We use paraplast instead of paraffin wax. There is no need for rapid cooling. Ribbon sectioning is easy and permits large blocks and dense bone block to be cut with relative ease. The melting point of paraplast is 56 to 57 degrees Celsius. The carbowax, if it is used, it is good for many enzyme and histochemical studies, and there is less shrinkage and distortion of the tissue. Thank you.